Today, we're going to learn how to erase a node from a binary search tree. Hello, I'm James Helfrich. Removing a node from a binary search tree can be tricky because we got to replace that node with something else if that node has children. This video will demonstrate how to do that. Erasing a node in a binary search tree has three cases. The first is when we have no children. In this case, I want to try to erase the node 9. Since 9 has no children, all I need to do is just delete the node. The second is when I have one child. In this case, I would like to delete the node 8. Now, 8 has a left child, 6, but no right child. In this case, I'm going to take the child and it's going to replace the position in the tree of the node we are erasing. The final case, I have two children. In this case, I want to erase node B, and B has both children A and F. In order to do this, I first have to find the in-order successor. The in-order successor is next in sort order, which is I'm going to go for the right child and then as far left as I can. Now, the in-order successor must have 0 or 1 children. If the in-order successor has 2 children, then it must have a left node, which means that left node would be the in-order successor, not this node itself. So in this case, I have D, and D is going to replace the position of the erased node. And then if there's any children to the in-order successor, it will take the in-order successor's position. Let's do a couple examples. First, I like to erase node G. Step number 1, I need to find G. So I'm going to start at the root. And since G is less than K, I'm going to go to E. Since G is greater than E, I'm going to go to G. And I found it. Next, I'm going to identify the case. I have one child, and that child is I. Then I'm going to find the in-order successor, which is I. And then I'm going to erase G. And so that means that the erase node is going to take G's spot. There we go. Second example, I like to erase node E. So I'm going to start at the root and I keep going until I find E. There we go. I'm going to identify the case. I have two children, which means I must find the in-order successor. And then I'm going to find the in-order successor. So I'm going to start at E. I'm going to go right and then as far left as I can go. And that gives me to F. And then I'm going to erase E, it's gone, and I'm going to place the in-order successor in E's spot. So F goes there. This is example 6.3 and 6.4 from the C++ data structures textbook.